All right, today we are diving deep. We're going right into the heart of the modern AI data center to unpack a partnership that's tackling the single biggest bottleneck in scaling AI, and that's the network. We're talking about Cisco and Nvidia and how they are literally re-architecting the fabric that holds AI together. So this is really where the whole story begins. You've got these massive AI workloads. I mean, thousands of GPs all trying to talk to each other at the exact same time. It's creating this insane traffic storm that our traditional data center networks, well, they just were never, ever designed to handle. We're facing a networking challenge on a scale we've never seen before.
And that brings us to the big, scary question, the one that keeps engineers and executives awake at night. You can have the best, most expensive GPUs in the world, but if they're just sitting there, waiting for data, your entire multi-million-dollar investment is literally grinding to a halt. And the reason why? It often comes down to something as small as a single dropped packet.
Now, at the core of this problem is a protocol called ROC-v2. The easiest way to think about it is like a private, super-fast highway just for GPUs to talk to each other, completely bypassing the slow CPUs. But the price you pay for that incredible speed is a major weakness. It has zero tolerance for packet loss. A single dropped packet, just one, can cause a traffic jam that stalls the entire communication, bringing that hugely expensive training job to a screeching halt.
So how in the world do you solve a problem that fundamental? Well, you bring together the absolute titans of their fields. You get the leader in networking, Cisco, and the leader in AI compute, Nvidia, to join forces. And this isn't just, a simple product integration. No, this is a deep strategic alliance to build a whole new kind of Ethernet, one that's truly purpose-built for AI.
And you can really feel the weight of that in this quote from Cisco's CEO, Chuck Robbins. It's all about ripping out the barriers, getting rid of the complexity, and making sure that customers can actually get the performance they're paying for. It's about unlocking the real potential of these massive AI investments.
Okay, so we've talked about the why. Now let's get into the how. We're going to go inside the architecture of what's called the AI backend fabric. This is that super high-speed network that's dedicated to one thing and one thing only, that critical east-west traffic, the nonstop conversation happening between all the GPUs.
So what you're looking at here is a classic spine leaf design. You might have heard it called a closed network. It's built from the ground up for non-blocking, super high bandwidth performance. But the really clever bit is what they call the rail-optimized layout. This just means they very carefully cabled the GPUs to the leaf switches to keep most of the chatter just a single hop away from each other. And that absolutely crushes latency. And look, this isn't just some drawing on a whiteboard. It's built on some seriously powerful hardware. We're talking about switches like the Cisco Nexus 9100 and 9300 series. These are the physical beasts, the workhorses that make that high-speed, low-latency fabric a reality. And they're powered by some of the most advanced silicon you can find. And speaking of that silicon, just look at the progression here with Cisco's Silicon One ASICs. The bandwidth literally doubles with every single generation. We go from 25.6 terabits per second with the G100 up to 51.2 with the G200, and now a mind-boggling 102.4 terabits per second with the G300. And each step of the way, they're adding features designed specifically for AI, like the intelligent collective networking in the G300.
Okay, now we're getting to the real secret sauce. This is the technical heart of the entire solution. It's this elegant, real-time coordination, this perfect handshake between the Cisco switch in the network and the Nvidia network card, the NIC, that's sitting right next to the GPU.
So let's walk through this. First, a GPU sends its data to the Cisco switch. Now, instead of just sending all those packets down one potentially crowded path, the switch does something incredibly smart. It uses a feature called per-packet dynamic load balancing to intelligently spray the packets across every single available link. Now, because of this, the packets are obviously going to arrive at the destination all jumbled up, completely out of order. But, and this is the magic part, the NVIDIA BlueField 3 SuperNIC on the other end is designed for this. It has dedicated hardware that instantly reassembles all those packets in the correct order and feeds the data perfectly into the destination GPU's memory.
So what you have is this incredible closed-loop system that takes what is normally a gigantic networking headache, out-of-order packets, and turns it into a massive strength. It allows the network to use 100% of its available capacity all the time by smartly routing around congestion before it even has a chance to form. Now look, having all this amazing hardware is one thing, but making it all work together reliably at scale, that is a whole different ballgame. And that's where you pivot from the hardware to the beautiful simplicity of software automation.
I'm sure any network engineer watching this is nodding their head right now. Manually configuring a lossless network, tuning all those little settings like priority flow control and explicit congestion notification, it's a total nightmare. It's complex, it's tedious, and one tiny typo can bring your whole operation down.
And this is the answer. The Cisco Nexus dashboard. What you're seeing here replaces weeks, sometimes months, of painstaking manual configuration with a few simple clicks. You literally just tell it you're building an AI fabric, and the system automatically applies all the industry best practice configurations for you. It's a total game changer.
So what exactly is it automating? Well, it's fine-tuning all those critical technologies, things like PFC, which sends out pause frames to prevent packet drops, ECN, which gives you an early warning that congestion is building up before packets start dropping, and of course it activates and configures the dynamic load balancing. It takes all of that incredibly deep expert-level knowledge and just makes it an automated, reliable part of your deployment.
So what does all this power, all this automation really get you? This isn't just about building faster networks for today's AI models. No, this is about laying the foundation for what's coming next, the era of autonomous, agentic AI.
I mean, the scale we're talking about is just breathtaking. The Cisco N9100 series, which uses Nvidia's Spectrum-4 silicon, already pushes a massive 51.2 terabits per second. But the next-gen Cisco Silicon One G300, it doubles that. It doubles it to an almost unbelievable 102.4 terabits per second from a single chip.
But what does all that tech actually mean for the business? What's the bottom line? It's this number right here, a 28% reduction in job completion time. That means your AI models train faster, you get your insights sooner, and you start seeing the return on that massive GPU investment that much more quickly. Now that is a number that gets everyone's attention.
So let's just end on this thought. We're moving so fast, we're going from just training these big models to deploying entire fleets of autonomous AI agents that need to talk to each other constantly, instantly. So the question isn't, is your compute ready for AI anymore? The real question is your network ready to become the central nervous system for that intelligence?